Hello everyone, welcome back to another part in our RTS series into making inside of Godot. So, sorry about the last week, I could not upload a video, I had some work to be done, and now we are here. So, what I have been up to? Well, now we can actually gather our resources and deliver them to a building we have specified here. So, pretty cool stuff. So this is what we're going to be showing you in this video. And as you can see, the units will carry over the resource and deliver to the building. And after it has finished collecting all the resources, this tree node is going to be the spawn, which is basically queue free. So as you can see, there we go. And all the information we have here under the prompt window is, as you can see, the gather information, the amount of resources the tree still has, the amount of carrying capacity this unit has, and as you can see by the debug here, everything is working as it should. So in order for us to do this, there's going to be quite some relevant changes here into the code. There's a lot of things we need to touch up. So as you can see, it is working as it should. The units get resources, stock them inside of the stock building. But for now, the stock building doesn't actually add the resources back to the faction. It just resets the resources on the workers to be equals to 0. So there we go. And as you can see, there are some information here on the debug that is going to be present inside of the code to make sure that everything is working as it should. Of course, in the game, you're not going to see any of this information, but it's really cool to see how it's working behind the scenes. So this is basically what I want to achieve in this part from the last part, and let's see how to do it. So let's minimize this one, which is the reference project, and let me actually open here and I'm going to go ahead under my last part that have been published, which was the part 6. Let's duplicate that, and now is the RTS project part 7. So this will be the next part. It's going to be on the Google folder that you, if you are a YouTube member, you can access to this folder. So yeah, this is going to be the next part, and let's see how we are going to be building from the last part. I don't even know where we're left off. So yeah, a couple of things here to do. So let's deal first with the simple ones and deal with the more complicated things later. So let's add a new building. It's going to work as the stock building. So let's add a new mesh instance here, which is going to be a simple box mesh. And I believe it was 3, 4, and 8, or 4, 3, and 8. So the dimensions of this cube, and I'm going to lift it above ground. Yeah, very simple stuff. 1.5 under the Y, and we're going to pick a position. And I believe I picked this spot over here because it was the most suitable to be placing it. So yeah. Now in order for our navigation to also bake this type of information, let's go to node and assign to the RTS mesh group. So now we can bake this information, and it's going to rebake some navigation avoidance. Now in order to get rid of this top layer of the navigation, let's access our navigation node here. And let's go under regions, and there's a minimum size here. Just put a high enough value that's going to delete this amount of navigation, and I believe even inside of the tents is going to have some information. So now whenever you have set the minimum size and you rebake, you're going to see it's going to get rid of this and potentially affect other areas as well. So you can just leave some value here that is going to exclude that top layer while still keeping everything as it should, as you see here. So yeah, I think this is fine. Let's leave out this one. This is minimum size. Okay. Now let's hide the navigation area. Okay, so good to go. Next, I'm going to rename this as the stock building 01. So we're going to use this for later. And let's now add a method inside of our RTS world to grab the reference to this object, which we're going to use very quickly. So let's go ahead. So I'm going to add here the variable and a simple function so we can just get the stock building if we need it for some reason. So there we go. And I even think we can just leave the stock building. Yeah, let's leave out this. And I'm going to go ahead and as well set up a function here. So whenever we start, whenever we enter the tree, I want to assign this to be inside of our globals. So let's quickly jump here to our global script. So the auto load globals, and let's add a variable here that's going to be our RTS world. So we need a variable that's going to reference the RTS world. This is because whenever we are fetching nodes, we need a variable to access them, because some variables are not exactly static, like the reference to nodes and stuff. So we're going to need that. And also we have a type, which is basically the script of the RTS world, which you should probably still have from the last part. So what this basically means is that whenever we start the auto loads, the globals should be the first one to run. So it's going to start this variable here. Then whenever the scene starts, we're going to have our RTS world. Whenever it enters the tree, so if I go back to the code of it, it's going to access our globals and it's going to define that this is actually the RTS world variable. So we're going to basically assign ourselves as the RTS world. And now, in order for this to work, let's just save and let's see. It should be good to go. Okay, there we go. So now we have a reference back for the RTS world from the globals, which acts as a access point. So this is going to allow us to basically grab the reference for the stock building from these nodes. Now, of course, the code yet will have a function that is going to say fetch the nearest stock building. Is going to always point to this one, as you can see on the function of the RTS world. Is going to just point a node which was the one we just built. This is temporary, as you can see by the name of the vars, that later we have to build a function that is going to grab all of the buildings of the player and sort them out based on distance against the worker, so we can fetch the closest one based also on resource type. So for now it's going to point to always this building, and because we are not even working with resource types, this is going to work as it should. Alright, so this is the easy steps done. Let's go ahead and get our feet wet inside of the code. So now I think it's a good time to start adding stuff we did have since the last project. So I'm going to hop here under the WinMerge app, which is this one, which allows you to compare different folders and files, etc. And as you can see here under the files of the project, we have two scripts that we do not have on since the last part. So let's go right ahead and add those. So I'm going to do this inside of the project itself. I'm not going to copy and paste anything because I think it's a little better to do it. So let's go under our RTS object state scripts and let's add a shared script here. So the idea is to group common used functions inside of here so we can actually call them from different states. So this is going to be called shared, and we're going to basically share common functions inside of it. So if I just paste the code for that, what that looks like is that for now, we only have a function here, which basically requests a new movement for a given object. So this basically allows you to call this function and just say it to make this unit move to its goal object path. So the code is very simple and it's basically a copy and paste of different code parts we already have. I believe under the state idle we have the code for this. So I'm going to just check for this. And as you can see, this is the function that does this. But first, before we call this, we need to actually declare this. So let's head up to our autoload scripts and add here our shared. So this is going to be the state shared functions. So let's add those here where it's most close. And let's see if the path for this file is correct, and it should be. So it should be inside the RTS scripts object state shared. So as you can see there, that is one file script we have done. Now for the other is actually the AI state of stocking resources. So I'm going to see which state is the most simple one. Just resize this. So this script that is the most simple one, I believe it's idle. Gather has some functions and it actually is movements. So let's duplicate, and I'm still going to do it with idle. So let's duplicate the idle script to be the state of stocking. And I'm going to actually just copy and paste the code rather than type it by scratch, because I think it's a little bit faster for the tutorial. And I'll go ahead and explain the code whenever it's needed. So for now, let's just leave at that. It's going to be a basic copy of that. So now let's go ahead and actually update some of the scripts we already have. because as you can see here, there's a lot of changes. So let's go ahead. The first one I'm going to update is going to be our object constants, our data constants. And I'm going to actually put here the new code. So one new big change you're going to see, I also have excluded a bunch of information and deliver new ones, is I have done some changes here. And as you can see, all of them are stuck together, and I have added a couple of entries here. So what's the idea behind this? Because we are using enumerations as integers, whenever you for some reason get a debug message that says error without data, I believe it's going to throw up the error if we try to run the project. Yeah, so in this case it shows up as the move speed, and I believe that's because now it's actually object move speed. So let's go very quickly to the object action move, and let me just replace this so I can try to run the project. So move speed is now actually called object move speed. Let's replace this inside for the entire project. We have only 2 references. Let's save. Let me try to run the project again. I just want to show you that we're going to probably run into issues with the data being different, and that's not the case. So let me just do something instead. I cannot try to show you, but basically whenever you have a bug inside of the code, it's going to show up the enumeration as an integer rather than the full name. That previous bug, because it was a bug inside of the editor, it actually shows the error of the variable name, but otherwise, if it was an error during runtime, you're going to see that it's going to show up basically an integer, and it's not going to show up the actual name of the enumeration, where I wish it kind of did. It kind of did that because it is a lot more clear to debug. So the idea with putting these lines here is to exclude the starting lines, and every number you see here is going to correspond automatically the number of the enumeration. So whenever we have a bug that says that this object doesn't have the number 15 in its object data, I think I can show you what I want to show by basically excluding input, selecting the object. So let me go here to 3D, select this node. And as you can see here, under object data, voila, a bunch of random integers. We don't have a clue what they actually are. But because I have done this, 0, 1, 2, and 3 entries are basically listed as reserved. So object action ID is number 4. So let's see if we can find the integer number 10 is actually if the object is selected or not, which is true. If I go back to the game here, you can see that the object is selected. So if I select this one and go towards object data, number 10 is not checked, which corresponds to the number 10 here on the line. So this is a workaround, like a hack, to make the enumeration the same as the line of you see here. So we have a little more easy information to debug, as you can see here. For instance, here we have the enumeration number 24, which is the resource amounts. So there we go. That is the intended usage for this. That is why I have placed these numbers here on top, to allow us to debug information a lot more easily. So this is the full list of the object data. You can see what has changed and update your own code. So I believe that is all we have for the object data. The other one we have to update is for the states constants, because we have a new state, which is stock. So we need to add that inside our object state constants, and also in the main manager we need to update the reference here. So let's duplicate this one, add the state of stock to be equal to the script of state stock, which should be here. So now we have a reference here. And I believe that's all for it. Now let's go ahead under our object data prefab, and I also did some changes here. So if I just place the code here, you're going to see that I have added some entry types and changed someone. So previously I was calling resource amounts for the resources stored inside of the unit, but now I believe that have specific enumeration is going to work best for this type of thing. So now I have actually switched for gather amount, which is a new object constant you're going to see here, which is gather amount, and now it belongs to the class of the unit worker. So these variables is going to be added automatically back to the unit worker. And also we do not have the state of null, so let's add that. So here I also have added a state called null. So the null state is the same idea without using null, because it's a different object type than a enumeration, which is basically an integer. So this is going to work as R0. So in the database here, we are using the object next state to be equals to null. So by default, whenever a unit starts, it's going to start on idle state, and we're going to leave the next state as null. And I'm going to show you why we're going to use the object next state. This is a feature for the finite state machine that we didn't have previously. So I believe this is all the changes for the prefab database. So let me update now another big change. So previously, our state gathering had the responsibility of actually performing the gather function, which is this one. So I have completely rewritten the gather function because it's the most important one, especially with the prototype reference you saw where it actually gathered some information. So I have changed a lot in the script, and I believe this is going to be the most focused on this tutorial. So for now, I'm going to basically strip away the gather function from the state of gathering. We're going to make this inside of the action. So if I delete this, it's going to throw an error because we do not have the function yet. So I'm going to save now, go and switch to my action of gathering, and here I'm going to basically paste the function that's going to perform the gathering action. So this is going to be the most important part of the code. So I actually don't want, yeah, I can copy everything I have from the other project. So this I'm going to explain later. For now, let's just leave as it is and go back to my object of state of gathering, and let's see what else changed. So here, in order for us to call the gather function, since we no longer have it in the state of gathering, we need to actually call it from the action itself. So here, instead of calling the function directly, we're going to access our scripts, grab from its actions the script we want, which is the script ID action gather, and from there we're going to call directly the function gather for this object caller, which is going to perform the gather itself. So that's basically the idea. So now the gather function is no longer in the state of gathering, it's now inside of the action gather, which should be the place it needs to be. So we're going to go right ahead and save this one. So something else we're going to change here is whenever we exit the state, we previously were always deleting the target value from the units to be itself, which basically is turning itself to null. Now we are not going to do this anymore because this is going to be handled by the function itself. So through other methods, we're going to clean up the object target. So for now, we're only going to stop this cycle timer. So this is going to break whatever logic you have built up. So we're going to see how to fix this with the code changes here as well. So let's save the script. And the last act we're going to add here is whenever we execute the states of the gather, we're going to change a couple of things. And as you can see, a lot of code here. So let's see what changed here. So we're going to leave this print statement inside. So whenever we don't have a target, we're going to switch back to idle and pass a print statement for debugging information, which is going to say that this object doesn't have a target, thus it's going back to idle. However, if something else is going to happen, we're going to do the following here. So we're going to access a constant called gathering distance squared, which belongs to the action of gathering. So as you can see, the action of gather on the top here has now two constants, a constant for stocking and a constant for gathering. So this is almost collision information we will have built, and I believe we also can use AABBs later. For now, we're only using the simple distance to make sure we are close enough to the objects in order to stock or gather. So that's the main idea with that. So the code for the state of gathering, if I could get back to it. On here is, as you can see, we grab the constant from the action of gathering. Then next we're going to say that if our target resource global position distance squared is higher than the gathering distance, we're going to print that we are not close enough to the target resource, thus we need to move to the resource. How we move to the resource? First, we need to assign this as a object new path goal, as we have done previously with other states. And this is going to be the target resource, which is going to be assigned whenever we grab the object target variable. from the object target from the object caller, which is going to be the worker. So the target resource is going to be the tree object we're going to assign through the user UI output. So whenever we right click on the tree, is going to pass that as an object target, thus allowing the state to execute. So we're going to move to the resource and we're going to access our script state shared functions, which is basically a copy and paste place for us to hold common use functions, which is like this one, which is going to make our units request a new movement to use its own systems to move towards the object new path. So this allows us to group important functions together to reuse them with the same functionality. So after it has done that, we're going to assign the next state to be the state of gathering. So as you can see, this is how the next state functionality is coming in. So we're going to have an object's next state is going to dictate the next state once this one has ended. And we can use this next state however we see fit. It is only a constant definition inside our object database, which as you can see here is object new state. So all it does is basically say the next state is going to be the state of gathering. So this is going to be implemented by the state of movement. So whenever I finish the path, we're going to check if we have a next state or not to execute it. So this allows us to chain states together in order for us to know that a unit is going to move towards the tree, and whenever it finishes moving, we want to start gathering. Because otherwise, whenever you finish the state of movement, it's going to stop right there and do what? Go back to idle. Because that is what the state of the movements does. Whenever it doesn't have, if it is not gathering anything, it's going to change the state back to idle. So the idea of using the next state is whenever it finishes moving towards the tree, it's going to end the state of movement. And here, whenever we do not have a path, we're going to check if we have a next state. So that is the main idea with having a next state variable to chain states together. So we can do this. We can request a new movement towards the resource because we're not close enough to it whenever you say that we want to gather, but we are far from it based on this line of code here. So that is how we are going to do this. So the state of gathering, whenever we execute it, and if you remember, our object unit is going to execute this state based on the, for now, physics process rates. So this is going to run a lot, and it's going to run through the state manager and executes the current state, which if it was on state of gathering, is going to run this code. So that's the idea. So this concludes all the changes to the state of gathering. So we are finished with this state. So we have removed the entry which resets the object target, and we have added a couple of lines here under the execute state. That's all for the changes of the state of gathering. So now that we have finished the state of gather, let's go ahead to the new state we just made, which is the state of stocking. Now this was previously a duplicate of the idle state, so let me just paste here the new code for the state of stocking. And we are going to see how this works. This is the state that once you have gathered the resources, is going to assign this unit to go back to a storage unit in order for it to stock the resources it has grabbed. So this is how the code works. First we enter the state of stocking through the enter state whenever this as state is being executed. Now whenever we need to start and execute the state by the physics process, this is how it's going to perform. First we need to grab the current stock building. So for now this is a direct reference to the RTS world, which is going to grab it from the RTS, from the globals RTS world temp stock building. And I'm not even using the function which I defined, which is going to return the current stock building. So I think you can also delete this line and just keep the reference to the node we just built, which is this guy here. So the word RTS main only has the reference to the stock building, which the state of stocking is going to grab whenever we want to execute the state. So it's going to say if the current stock building is equal to object caller or the instance is no longer valid, which is the current stock building. So whenever we do this type of check, if you remember from previous part, is basically saying if the current stock building is equal to null. So whenever I reference the object himself, I'm basically saying that this is the null object. This is because it's of the same type as this object, because the function under object data manager uses the for safekeeping of the variables, whenever we set a new one, I want to keep the same type of variable. So in order to be able to do that, I'm going to checking if the current stock building is equal to ourselves. We know that if this happens, this is a new reference. And also if this instance is valid, because this instance can be deleted by queuing free. So if there are no invalid or stock buildings, so it's valid for us to stock, we're going to set a reference here, so we know that this is the current resource stock building. So if you remember, this is going to be run by every physics process frame rate. So whenever the current stock building is empty, it's going to fill up with the reference we just assigned to the global RTS world. So later you can basically assign this to be the RTS world to request the closest stock building to these units to store resources. But for now is only a direct reference, and it's going to return because we do not want to keep processing the function, because we need to skip the other parts. Because this variable here also depends on this value, so that's basically it. So the first question we're going to ask inside of this state is, are we close enough to the stock building? So we're going to grab the variable which is a constant, which represents the stock distance square for the action of gathering, which allows us to know if this object global position distance squared to the stocking building position is less than the stock distance squared. So if that is the case, we are closest to it enough, so we can start stocking resources. If that is not the case, then we are far away from the stock building and we need to move to it. In order for us to move, we need to first set the object new path goal variable inside of our units, then next call for the state share functions to request a new movement, then set the next state to stock. This is also another usage of the next state. We want the units to move back to the stock building, and the next state is going to execute it once the move finishes, is to stock the resources. So here is another appliance. And we also are going to print the statement of the state stock has prints the object name and cannot stock because it's too far. So whenever it finishes moving, it's going to run this function again. And if it's closest enough, we're going to do the following. So if we are inside the deliver range for the stocking, we're going to stock resources. So we first need to grab the amount of resources we have, which is basically inside of the object as gather amount. And then we're going to print a statement that says that this unit has stocked the amount of resources. And the actual stocking is not a stocking. We are simply reset the gathering amounts to 0. So later we are going to build a faction player to actually store the resource and to display it for us here as a UI element. So for now, we're just resetting the amount of gathering to 0. Next, our worker last resource is going to be checking. So we know we have delivered the amounts. Now we need to go back to the last resource. Whenever the units have gathered from this tree and this worker was assigned to this tree, it's going to move back to this position to grab nearest trees from this one. So it's just going to be one of these. So we're going to use this var for this. For now, we also have a reference directly to the last gather resource. So whenever a unit has gathered resources from this one and has been delivered inside the stock, it's going to automatically check if this resource is still valid for us to go back to continue gathering resources to also go back to the stock builder later. So this is what this part of the state is going to do. That is the logic. So we need to grab the last resource reference, which is stored under resource gather object. Then next we're going to say that if this worker last resource object is not null by checking if it's different than ourselves, which is how I am declaring null. And we're going to check if it's still valid. So if that's the case, we're going to say that inside of our stock, we're going to say that the resource we were collecting is still available. So we're going to move back to the last gather resource. Then we're also going to set a next state because we want to move back to the tree to start collecting resources again. So we're going to assign the next state to be the state of gather, which is going to point back to all of this code here. And we're also going to set the gather of these objects to be the worker last resource. So this is going to allow our objects, if they don't have the object targets, to go back to it. So that will be the case if the resource is still valid. So we're going to do all of that code and is going to go to the other states. So if our worker last resource is null or is invalid, we're going to say that the resource is invalid and we're going to go back to state idle. So later we can also request the RTS world for new resources, because we are collecting, we got back to the stocking, and this resource for some reason is no longer available. Maybe another unit already collected. So this unit is going to say to the RTS world, I need a new resource of the same type. So we can use the last resource no position to know that from this position, where are the other resource types. So the RTS world can say all of those resources are the closest one for you to go back to. And I actually am doing a lot of things that I shouldn't do. Let's see if I didn't break anything, hopefully not. So that is the bit of code that's going to tell this unit to go back to the last resource object. So we can do this later through the RTS world, mainly because I also want to develop functions to split the world into grids, so it's going to be more performance. So for now, it's going to switch the state back to idle. So whenever this resource is no longer available and we finish delivering the resource, it's going to stay put back in the stock building, it's going to return to idle. So that is basically all of the code for the state of stocking. I believe I also explained this one, which is whenever we are far away from the stock building. So this is all of the it does. And these signals here, I don't even believe we actually need. So we can type it later, but no, all of those are unneeded. So this is reference code temporary. So I just have a patch guard here of what it looks like. So yeah, this is all of the code that the state of stocking is going to perform. So very simple code. This is the entire code for the state of stocking. So now I believe the last code change is going to be for the state of movement. So let me select here and update with the new code. So not a whole lot has changed here, just a couple of lines, a simple line of comment here. But the most important part of the code is we need to use the next state variable whenever the state of movement doesn't have a path to continue movements. This means that the unit probably has reached the end of the path. So for this to work, we're going to check if we have a next state to switch. So the next state is going to be equal to our data manager get data variable from the object as object next state. So if the next state is not the state of new, which is quite important, so that is why we have defined under the state constants for the, we have a null state, so we can use in functions like these. Then we're going to say if we have actually a next state, we're going to switch the states to this next state. This is quite important. This is where the chaining of states is going to happen, where this state of movement is going to switch to the next state as we have assigned. So later, after we have used the next state, we're going to simply turn it to no, so we can no longer use it again for some reason. But this also can change based on the behavior you want to code. And we're going to skip from this function because we want to use the next state, not to do anything else. So that is basically all the changes for the state of movements. So now the last thing remaining for us to do is for me to explain the action of gathering. So let's go right ahead because this is going to be, I believe, the most complicated one. So there's going to be some similarities, but you will see what I mean. So the object action gather has been rewritten. So we already explained the use of the constants from the code from the previous talks about the other states. Whenever we initialize this action based on the requirements, we want some variables to be inside of the object, like the resource gather last node position, the gather resource, and the resource stock building reference. This is just information we don't want to add to the prefab database right here, but we want to be initialized by whatever unit uses the action of gathering. Whenever we execute the state of gathering, we want to pass the reference to object caller. So first things to do is to grab the reference to the target resource object, which is going to be stored under a variable called object data object targets. This is the target resource object, aka the tree you have assigned by the player to this object. So we're going to say that first we want to say if this object is new. We do that by checking if it's equal to ourselves, which is how I calculate new. So if the resource is new, we can do a couple of things. We can ask the RTS rows to grab new resource. We can ask for it to return the current resource. But for now, we only put in an action that says that the action of gather doesn't have a target resource. So we are going to skip gathering altogether and we're going to return away from this function. So if you remember, this is going to be called by the state of gathering whenever the resource cycle timer gets called for whatever reason whenever it's gathering. So that it will be the only time that this function is going to be called. So skipping from this is going to leave opportunity for the execute state to exit out of the state based on these conditions. So if that is not the case and the resource is still valid, we're going to first rotate to the resource. This is duplicate code to make it look a little better on the prototype. It's basically a look at under our target global position. And now we're going to need to do some things. So we're going to need to assign this gather resource as the last gather resource position. This is going to allow our state of stocking to go back towards this resource. So whenever we assign the new resource, we're going to move towards it and we're going to assign this as the last gather resource. So we're going to assign this as the last resource node position and as the current resource gather object under these vars here. Next, we're going to define a couple of vars here. First one is, what is the current resource amount? This is going to be stored under the target resource, under the variable of resource amount. Next, we want the worker gather amount of resources per cycle. So this is going to be stored under our object caller, which is going to be the worker, under the variable gathering amount per cycle. And this is going to be a dictionary var because we want workers to have different gather amounts. So if I go here to the prefab database, we have gathering amount per cycle, and the amount of wood is defined as 8. That is how we're going to use it here. We can later do this based on the resource type, but for now we only have wood defined, so let's use that. Next, we want the worker current gather amounts. This is almost like the inventory of the worker, how many space it currently is using. So this is going to be stored under gathering amounts. So previously it was called resource amounts. The same var for the resource was being used for units. Now we have a dedicated var called gathering amounts. Next, we want the maximum amount a worker can gather. This is going to be stored under the var resource carry max. So that is how we're going to retrieve it. Next, we want the amount we have left to be filled by resources. So basically the free space you have inside of the worker. So here we're going to start working with some math. So in order to calculate the remaining free capacity we have with the worker, we're going to do the worker max amount minus the gathering amount. And this is going to return us with the remaining capacity we can use for this worker. Next, we want to know the amount of resources we'll grab from the resource object. We're going to do this by using the min function. So the gather resource min function is going to be equal to any amount of those. So how does min work? So minimum function from the global scope is going to return the minimum value based on a set of arguments, which could be a lot of ones. So from all of these vars, we want to grab the lesser amounts, the smaller amounts. So first we want to grab the worker gather amount, so how much this worker can normally gather. So we want to grab the current worker gather amount, the resource gather amount, or the worker amount remaining capacity. So why we want the minimum size here? We want either the least amount we can gather, the least amount this resource has, or at least the remaining capacity we have free for this resource. So we either grab the current resource amount. So if this resource was 1 and we can grab 8, we will be able to only grab 1 because this resource only has 1. Or let's say that this resource has 300 units and we can gather 8, but we only have free space available of 2 units. So we want to grab the minimum amount, aka the worker remaining capacity. And as you can see, that is how we can do that. And here's a small example in comments because this can get quite tricky. The logic of this can get also complicated based on other stuff you want to do. So after we have calculated the amount of resources we're going to gather, we're going to need an amount that we're going to define for the resource. So after we have deducted these resources, we need a new one. And this is going to be the maximum amount. So why use maximum here? In theory, this should not surpass. In order for us to avoid negative values, I want to make sure that we want to grab the maximum value of either the current amount less the gather resource or 0. Because let's say that for some reason the resource current amount is 1 and we gather 2. I want to make sure that the new amount for this resource is going to be 0, not -1. So I'm going to use the max to invert the logic of this function to only grab the maximum amount. So the next question we're going to ask, if we have gathered anything from the target resource, we're going to do a couple of things. So if there was resource and we actually gathered something by checking if gather resource is higher than 0, we're going to print a debug statement that can show us the resource math, the gathering amounts, the remaining capacity, all the information you saw under the output of the project. This is just debug information. Next, we want to assign to tell the target resource we were collecting resource to deduct that amount of resource. This is going to directly access the tree object and is going to reduce its amounts to this new one. So this value is quite important. Next, the worker will add that deducted information on the resource back to itself as gathering amount. We're going to set that var of gather amounts to be equal to the worker current gather amount plus the gather resource amount. And that is how we're going to add resource back to the worker. So this is only happens if we have gather any resource at all. Next, we want to see if there were no resources amounts left again inside of the object. Because we use the max function, we can make sure if this is equal to 0. Or you can do this also as less or equal than 0. It's going to work the same way. But because we are using max, I want to keep it as equal. So if the case of the resource amount is 0, we're going to print a statement, which is going to say that this unit has empty a resource object. So now our current resource is, we're going to send a signal here, which is some logic we have defined for the states. And I don't even know if this state can use, the state of gathering has this signal. So let me check. So the state of gather has a signal called the resource is empty. If that is the case, it's going to switch this unit back to idle. So we can copy and paste this back to the code of the action of gather, and we can leave at that. Doesn't matter. You can see the power of our statements and action systems here in action, where it can basically choose one of the two. So in this case, it's going to fire up a signal that the resource is now empty. And later we can say that we want to instead ask the RTS world to grab the next resource to continue gathering. But for now, we're going to state idle and going to state put back into position, which is also unneeded because this signal already does that, but I'm basically doing it here as well. So this is a duplicate of the above. And we're going to set the worker target resource back to null because the object no longer exists because we already have collected everything. So we're going to access the resource gather object var and reset it back to null, which is basically reference ourselves. And that's going to only happen if their new resources amount is going to 0. If the worker current gather amount is higher or equal than the max amount of gathering, we can also do this as equal, but for safekeeping, let's keep this as higher and equal. If that's the case, we're going to print a statement that says that the action gathered for this object is full. And if that is the case, we're going to simply switch states to the state of stocking. So that is all the code for the action of gathering. If we have exceeded the amounts or equal to the maximum amount this unit can gather, is going to switch states with stocking, which is going to execute all of the logic for it to deliver and go back to this resource. The state of move itself is going to chain events through the next stage, which we assign under the stock, and gathering through assigning the state under the object next state variable. And that is basically all of the changes that should happen for your last project to also now be able to deliver a resource. And let's test it and see if we run into any bugs or something I have missed, which I believe I will not, because I have done this with a software to know all the code changes. So let's see, and let's grab resource from this one. So it's going to start gathering resources. Whenever it's full, it should go back. But we have some errors here. So the node was not found. And why is that the case? Let's see here. And I do not have placed the name here. One of those Ctrl-Z's I did is probably hasn't done the naming of that, so you can see a broken reference there. A minor issue. Now if we gather, we should have now resources gathered. Whenever finished resource is not going to stock because it doesn't have an object anymore. But whenever I fill the resource is going to stock and go back. And as you see, that is how I am doing the resource collection. Later we're going to do this and ask for the RTS world to basically work with resource types, and for us to also tell the units to work if this is an wood object, if this is a stone object, or a food object. And this is all the code to make units collect and deliver resources using the stock statement. So as you can see, powerful code. It's very easy to do, but because this is a tutorial, I have to explain everything, and it makes some things a lot more lengthy than it should be. But as you can see, the code is fairly simple. And later we're going to add a new faction player system, which is going to allow us to store the resources back to the faction player itself. So there we go. You should be able to make your units now go back and deliver stock resources back to your building, which is quite fun. And based here on the debug information, we can check if we are missing something or if everything is working as it should. So hopefully by following all of those changes to the code, you were able to duplicate this behavior inside of your project. If you want to grab access to this tutorial parts or the project source files itself, you're going to have to become a member for YouTube to be able to grab the keys passwords to allow you to unzip the files I post free under the Google Drive link. So that's all I have for you guys today. Hopefully you found this video useful, and I'll see you guys on the next tutorial. So thank you guys for watching, and hopefully I'll see you on the next one. So bye everyone.